Alright, so we are talking today about adding and subtracting polynomials and a little bit more about multiplying. But the first thing we want to follow up on here is a couple of things about polynomials. When you have polynomials with an addition sign in between, pay close attention to this because this is the common mistake, is that people think to start doing this, right, distributive property, because we talked about it yesterday, and then they'll start doing this. But that's not true because of this red addition sign here in the middle. So you look at that addition sign, and that means all you're doing is adding the terms. So really these parentheses are kind of unnecessary. You really just have 2x to the third minus 5x squared plus x. And then you're adding all of these things. So you're adding 2x squared, you're adding x cubed, and you're adding negative 1. So all you need to do is focus on what is similar. So this is a cubed, and this is cubed. So they have the same exponent and the same variable. That's the important thing here, okay? So we want same exponent and the same variable. And now we can add these together, which gives us 3x to the, and think about what you think that is before I give it to you. I'll tell you the answer. It's not to the 6th, it's not to the 9th, it's to the 3rd. You keep that same exponent. Let's go to another color here. We got this guy. We'll circle him. Squared. Do you see any x squareds? This guy, right? So negative 5 and positive 2, we're adding and subtracting here, so that's going to be negative 3x, and now you probably know it's to the second, because that's the rule for when we're adding and subtracting. This guy is lonely, he has nobody to be combined with, and this guy is lonely, he has nobody to be combined with, so they stay where they are, and your final answer becomes this right here. 3x cubed minus 3x squared plus x minus 1. Okay, so moving on to the next one. Let's just take this and kind of move it out of the way, and we'll see if we can kind of squeeze in here and make this happen. So think about what this would be. Maybe take a moment to try it before I go on, and then we'll start doing it. So let's see. It's addition again. We don't even need these parentheses. All we need to do is combine some more terms. So that's 4x to the second, keep the power. That's 5x, and then that's positive 4, and that's it. That's the answer. So that's how you add polynomials. Let's go on and subtract a few polynomials, and if you can get down how to add and subtract the polynomials, we'll give a little quick trial, a little quick test, and then we'll take it from there. So here's subtracting polynomials. Here's the only difference with subtracting. You're subtracting these things, all of them. So if you're subtracting a negative, let's say, for example, what do you think that is? If you're subtracting a negative, what do you think? Well, subtracting a negative actually makes it a plus. And subtracting a positive is just subtracting. And subtracting a negative again is 4. So basically what you're doing is you're kind of distributing that negative to everything. You're doing nothing with the 4n squared plus 5, and now it becomes exactly the same problem as we worked on just a second ago. Combine similar terms, same variable, same exponent. That's 6n to the second, keep that exponent. 5 and 4 go together, that's plus 9. I'm going to put it at the end because I want to put this negative 2n in the middle. I feel like he belongs here, because I like to have it in this form, descending exponents. That's called standard form. So take a look at this one. Think about what you would do. Okay, here's your hint, is that you distribute that negative. So give that a shot real quick. See if you would get it without my help. Okay, here I go. So I did that, and then I'm leaving this alone. Great. So we end up with combining these to be just 1x squared, or just x squared. We combine these to be negative 2x, and we combine these to be positive 13, and that's our answer. Okay, so that's pretty much what we're looking for here. Maybe we'll try a couple problems, and then we will continue onward, okay? So hopefully you've checked yourself, you've seen a couple of different examples, and now we will move on to some different things. Okay, so this is the time, if you're not getting it, to really make sure you check in with me or you know, just figure it out, okay? Because we're going to move on to something a little bit different now. We're going to talk about a real-life problem with polynomials now. Let's say, for example, we have a penny that's thrown down and a paintbrush that's dropped. So you can see here, there's a penny that this guy dropped. It's a huge penny for some reason. I'm not sure why that penny is so massive, but it's a big penny. And there's also a paintbrush that was dropped. So that's good. So pretty much what we want to do is figure out what the height would be if we were to kind of combine these together. So they say write a polynomial that represents the distance between the penny and the paintbrush. Well, the distance between the penny and the paintbrush, well, here's the distance between the penny and the ground. Okay? And here's the distance between the paintbrush and the ground. So red and blue make purple, so really it's this distance that we're looking for, right? But the distance between the penny and the ground is, in fact, this. And the distance between the paintbrush and the ground is, in fact, this. So if we were to subtract those, because let's say, for example, just with numbers, let's say the penny was up there 100 feet, and the paintbrush was up there like 40 feet, right? If that was the case, then how far would this purple line be? Well, that'd be 60 feet, right? So really what you need to do is subtract the red from the blue. So we're going to just simply subtract the red from the blue. We might even be able to just do it like this. Like take, this is really pushing it, but take the negative 16t squared and subtract negative 16. Well, that means that we're going to add it, and we're going to subtract this. We're going to subtract these now. And I changed the signs to subtract. So this is going to cancel. I got the negative 40t, which is all by himself. And I got plus 200 and minus 100, so that's going to end up being positive 100. So that is the answer to part A. Okay. Now we're looking for part B. Interpret the coefficients of the polynomial in part A. We're actually not going to do that right now. I do think it's interesting for you to see that the starting height is 200 and the starting height of this is 100. This is actually this right here, if you look at this coefficient, is the speed of gravity. This is kind of how gravity works, and we're going to get more into detail with that. That's a kind of a quick answer on it. Here's the difference, though. The penny was thrown, and that's why this is negative 40, because this person whipped the penny at the ground. But the paintbrush was dropped, so there's nothing here in the middle to contribute, to add to that speed. So just a quick discussion of this. We're not going to get into too much detail with it, but I thought maybe it would be good for me to quickly interpret those coefficients. All right, let's move on. So the last couple things here. Two types of different polynomials. Well, if we have, for example, a polynomial with, let's see, if we have a polynomial with a squared, for example, like this, well, what we're going to want to do is just simply multiply it by itself, because that's what squared means. So we're just going to take x minus 3 and multiply it by x minus 3. And then we're going to do this out. So what's that going to be? Well, we should probably just change colors here. X squared minus 3x. We talked about this yesterday, I think. Minus 3x plus 9. So now we're good. So now we have x squared minus 6x, which is this, plus 9. So we should be pretty comfortable with that. We could try this one here. But there's one other thing I want to show you about this right here. So if you look at this problem right here, how is this going to come out? Well, we'll have x squared minus 3x. And then we'll have 3x positive minus 9. So what do you notice happens with these? They cancel out to 0. You wind up with just x squared minus 9 because that goes away to 0. And that's the answer. It's called a difference of squares. So I'll have you try this problem, and then that'll pretty much conclude it for today.